A few weeks ago I found this beautiful piece of tetrahedite tenentite ore on one of the mine dumps, and it had a very high assay via XRF. Now, XRF assays only tell you what the assay is in that one little spot. The overall will be different throughout the rock. If you believe in X-ray on just one single shot, you're higher than a Denver junkie. But this stuff is really high in silver, so we're going to do an assay on it and see what happens. So we go ahead and we decide to smelt it. We throw it in the furnace with the appropriate mixtures to dissolve it down and get a bead of lead. It will absorb all the precious metals. Once it's ready to cast and we have a good dissolution, we'll cast it into an ingot mold, which is what you're seeing right here. So the first thing we want to do is cast off the flux that does not contain any precious metals, and then everything will have contained into a lead bead, which we will cast into the second part of the mold. So we get most of the stuff off, and then we pour the last little bit. The lead will settle to the bottom of it, and then we will allow this to cool. Once this is cooled off, we'll do the next step to get the gold and silver out of the lead for whatever is contained, and then we can get an absolute assay of what was in that rock. So we have to let this cool for a little bit because we got it to an extremely high temperature. It was enough to melt everything down. So we'll find out here in just a second. Once it cools, we then turn it over, and that gets our lead bead out, and there's the compelled material right there, the lead assay material. So we break the flux off that, and then I'll hammer that bead down until it is free of any flux, and then that we'll get an X-ray on it. So when we X-ray it, we see there's a small gold content and a small silver content, and now we're going to compel it down to get rid of the lead, which will absorb in. I'm using an unconventional technique, but we're not trying to do absolute scientific data here, so I'm using a torch to drive the lead off and leave the precious metals behind in a bead. Most of the lead gets absorbed into the compel, and that's what you're seeing right here. Usually this is done in an assay oven. We're just using a torch. Right here I'm sparging it, so I'm adding oxygen to sparge it down a little bit to make it a little bit easier to deal with, and then I'll hit it back again with the torch until we get down to a small bead. Now with that bead, how much of that is lead, how much of that is silver, it's unknown yet, so I'm going to transfer it into an additional compel that's clean to make sure it's absolutely perfect. If we have a nice round bead, we know we've got a perfect compelling and we've driven all the lead off. And in this case, we actually did drive all the lead off because we had a perfectly round bead that was surprisingly larger than I expected. So the next step on this is we will weigh the bead and X-ray it to determine what the values are of that tenentite rock. Here we have the bead, nice round little piece of silver. We'll go X-ray that and do our analytic work to see what the value of that material is currently. So get that cool and go to the next step. Wow, over 1/4 gram of silver just in that particular rock. And when we look at the assay data on it, we figure out that it's about 90 ounces of silver per ton and about 1/3 of an ounce of gold per ton. That puts it at about $8,000 in value per ton, which is insane.